Hey everyone, welcome back. You ready to dive deep into some serious physics?
Always ready. I love this stuff.
Me too. It's amazing how much physics is all around us, even in everyday life.
Totally. Like, we're going to be talking about energy and work today.
Exactly. And
Mhm.
we'll see how those ideas play out in all sorts of scenarios, from roller coasters to sports, even just making a cup of coffee.
It all comes back to physics. And the best part, we've got some awesome sources to guide us, so get ready to have your minds blown wide open.
When most people think about energy, the first thing that pops into their heads is probably something like electricity or maybe even food.
Yeah, for sure.
But today, we're going to be focusing on a type of energy that's a little less obvious, maybe a little more under the radar, but just as crucial, thermal energy.
It's the hidden powerhouse.
Ha. Love that. So can you break it down for us? What exactly is thermal energy?
So, thermal energy is all about the movement of particles within a substance.
Okay, so like atoms and molecules.
Yep. The more those tiny particles are jiggling and vibrating, the more thermal energy the substance has.
So basically, the hotter something is, the more those particles are freaking out.
Exactly. And that energy can be transferred from one object to another in three main ways: conduction, convection, and radiation.
Oh, I remember those terms from high school.
Yeah.
But a little refresher never hurts.
No problem. Think of conduction like holding a metal spoon over a candle flame.
Okay, got it.
The heat from the flame makes the molecules in the spoon vibrate faster,
Right, so the spoon heats up.
and that heat travels up the spoon, even to parts not directly touching the flame.
Conduction. Okay, that makes sense. What about convection?
Convection is heat transfer through the movement of fluids, so think liquids and gases.
Like boiling water.
Exactly. The hot water at the bottom of the pot rises, the cooler water sinks, and this creates a cycle.
It's like a constant mixing.
Yep, that's convection in action.
Okay, I'm getting the hang of this. So what are radiation?
Radiation is a little different. It's heat transfer through electromagnetic waves. No need for any direct contact or a fluid to carry it.
So it's like how the sun's heat reaches us, even though space is a vacuum.
Spot on. Or how you feel the heat from a fire, even if you're not standing directly in the flames.
Whoa, that's cool. So we've got thermal energy and its three sneaky ways of traveling. What's next?
Let's talk about a biggie: the law of conservation of energy.
This is where things start getting really mind-bending.
It definitely is. This law states that energy cannot be created or destroyed. It can only change forms.
Wait, so like energy's always there, it just transforms.
Exactly. It's never lost, never gone, just changes its outfit.
That's pretty amazing.
It really is. Imagine a swinging pendulum. At its highest point, it has maximum potential energy, the energy of position.
Got it.
Then, as it swings down, that potential energy gets converted into kinetic energy, the energy of motion.
But even though the type of energy is changing, the total amount stays the same?
Exactly. That's the magic of the law of conservation of energy. It's happening all the time, everywhere, even right now.
I'm starting to see the world in a whole new light. Okay, so we've tackled thermal energy and the law of conservation of energy.
Now let's put that energy to work.
Uh-huh, good one. Okay, so work in the physics sense, not just the chores kind. What's the deal with that?
So in physics, work has a very specific definition. It's done only when a force causes an object to move a certain distance.
So, like just holding a book isn't work.
Nope, because you're applying a force to hold it up, but it's not moving any distance.
Ah, okay. But if I lift the book up onto a shelf,
Then you're doing work,
yeah,
because you're applying a force to move the book a certain distance against gravity.
I'm starting to see how this works literally. So how do we actually measure work?
Simple. The formula is work equals force times distance. So the greater the force you apply and the farther you move an object, the more work you've done.
So pushing a heavy shopping cart across a parking lot is more work than pushing a light one the same distance.
You got it. And lifting a weight all the way overhead is more work than just lifting it halfway.
This is making me rethink all those trips to the grocery store.
Yeah.
Now, you mentioned power is related to work.
Yes. Power is all about how quickly work is done. It's the rate at which work is done.
Okay, so two people could do the same amount of work, but if one does it faster.
Exactly. The one who does it faster has more power.
So a powerful athlete can generate more force or move faster, allowing them to do the same work in less time.
Think about a weightlifter who can snatch a heavy weight overhead in a split second. That's power.
Makes sense. I'm starting to see how these ideas connect.
And the best part, these concepts aren't just abstract ideas. They have real-world applications in all sorts of fields.
It's like we've unlocked a secret code to understanding how the world works. This deep dive into energy and work has been electrifying.
We've learned that heat is actually energy on the move, energy is always transforming, and work involves both force and distance.
And power is all about the speed of getting things done. It's like a whole new way of looking at the world.
I hope our listeners are feeling energized and ready to explore these ideas further. Think about how engineers use these concepts to design everything from roller coasters to hybrid cars.
Or how athletes train to maximize their power and efficiency.
There's so much to discover.
So keep those brains powered up, everyone, and we'll see you next time for another exciting deep dive.